In this video, we will calculate pressure for a non-ideal gas. And so this is our problem. You have 200 moles of nitrogen is contained in a 10-liter cylindrical container at negative 30 degrees Celsius. We want to calculate the pressure in the cylinder for a non-ideal gas. The information right here is typically given at the end of a chemical engineering textbook. So we will calculate TR, which is equal to temperature divided by the critical temperature, TC. Now this right here would give us, so TC is in Kelvin, temperature is in Celsius, so we need to convert Celsius into Kelvin. So we have negative 30. If we add 273.15, this becomes in Kelvin. And we would divide by TC, which is 126.2 Kelvin. So this would give us for TR as 1.93. Next, we will calculate VR ideal. And with these two pieces of information, we can get the compressibility factor, which is Z. And so this will equal V hat times PC divided by R times TC. V hat, we could essentially say it would be like liters over moles. And so we have 10 liters divided by 200 moles. So 10 liters divided by 200 moles times PC. PC is 33.5 ATMs divided by R. R is 0.08206 L ATM divided by K times mole times TC. TC was 126.2 kelvins, so 126.2 Kelvin. And so what we can do now is say that moles would cancel, liters would cancel, ATMs would cancel, and Kelvin would cancel, and so VR ideal would be 0.161. So now we have VR ideal and we have TR. And at this point, we would use a compressibility chart. There's a number of compressibility chart in various textbooks. You could also search the internet, but through using these compressibility chart, we would essentially match the TR value and the VR ideal value. So we would match TR as 1.93 and VR ideal as 0.161. And the part that it corresponds to for Z would be 1.77. Now this part right here, you would have to use a textbook or you would have to search for compressibility charts via the internet. So we would get 1.77. And if you're not exactly sure how to use compressibility charts, I would recommend just searching on YouTube like how to use compressibility charts. So our Z value is 1.77. And now we use the typical PV is equal to nRT formula. However, it's going to be PV is equal to Z nRT, and we will solve for P. So P is equal to Z nRT divided by V. So we said that Z was 1.77 times N. N we got as 200 moles. And R we had was 0.08206 L ATMs K mole. And finally, temperature was 243 kelvins. And this part right here would be divided by volume, which was 10 liters. And so now if we use a calculator, we would get 706.3 ATMs. This right here is the final answer to our problem. And that's all we need to do.